Hello, and welcome to our first video of our next unit, perimeter and area, and today we're going to look at areas of triangles and parallelograms. Alright, first shape we're going to look at, one of our parallelograms is a square. The area of a square is the square of the length of one of its sides. So, in other words, we could say that the area of a square is equal to side squared. Since all the sides are the same length, it's just going to be side squared. Area of a parallelogram is the product of a base and its corresponding height. So product, remember, means we're going to multiply these two things. So the area of a parallelogram is going to equal base times height. Now, one of the things about the word height, height is going to be the perpendicular distance between bases in a parallelogram. So if you notice my diagram that I have over here, I'm given AB and CD as two of my bases. This line right here, BD, is perpendicular to both AB and CD. Therefore, BD is going to be the height. We could also say that AD and BC are bases, and then CF right here, which is perpendicular to both sides, and it would be perpendicular to AD if I extended it out to F. That could be a height as well. But the height has to be perpendicular to both bases. Now, it doesn't matter which one we choose. I'll go ahead and use AB and CD as my bases, and BD is my height. So if I want to go ahead and label things, the base, like I said, is going to be 8 because that's the length of AB. And we know in a parallelogram, opposite sides are congruent, so it's also going to be the length of CD. And in this case, the height is going to be 4.5 because that's the perpendicular distance from AB to CD, or the length of BD in this case. So 4.5 is going to be the height. So to find the area, I just take my base, which is 8, times my height, which is 4.5, multiply those together, 36. And this would be in units squared, because I'm finding an area. Now, just to show you that it doesn't really matter which pair of bases and height that I choose, let's try this for AD and BC being my bases and CF being my height. So again, if I go ahead and label things, my base in this case is going to be 9, that's the length of AD, and my height, that's the perpendicular distance between my two bases, is going to be 4. So area equals base, which is 9, times height, which is 4, and 9 times 4 is also going to be 36 units squared. So it doesn't matter which pair of bases we choose, it doesn't matter which one's going to be your height, it just matters that you choose the corresponding height of the corresponding bases. Next we'll look at a triangle, and again these shapes are, triangle is something we found the area of previously. The area of a triangle is going to be half the product of the base and its corresponding height. Again, we have the word height in here, and we need to associate the word height with perpendicular. The height of a triangle in this case is going to be the perpendicular distance from the base to the opposite vertex. And again, we can write this formula as area equals 1/2 times the product of the base and the height. So 1/2 times base times height. Now in a right triangle, in this example number 2 here, the legs will serve as both the base and the height. Because we have, in a right triangle, the legs are perpendicular to each other, one of them is going to be the base and the other one's going to be the height always. In any right triangle, the two legs, one is the base and one is the height. And it doesn't matter which one is which. So in example 2 here, we know that the base is 4 times the height. So if we call the height h, then the base would be 4 times h. The area of the triangle is 50 square inches. We want to find the base and the height. So we're using the area formula. Area equals 1/2 times base times height. Okay, if we kind of list everything we have here, we have area, which we know is 50 square inches. As far as we know, the base is 4 times h, and then we don't know what the height is. Height's just going to be h in this case. So we're going to go ahead and fill everything into the formula. So area equals 1/2 times the base, which is 4h, times the height, which is just h. And we'll go ahead and simplify by multiplying out this piece right here to get 50 equal to 1/2 times 4h times h. 4h times h is going to be 4h squared, and then half of 4h squared is going to be 2h squared. So 50 equals 2h squared. We want to get the h squared by itself, so I'm going to divide both sides by 2. 2's are going to cancel. I'm going to get 25 equal to h squared, and to get rid of the squared, we use the square root on both sides. The squared and the square root are going to cancel out, and h is going to equal to, it should be plus or minus 5, but since we're talking about a side length here, we can omit the negative part. So h will equal 5 in this case. Now it wants me to find both the base and the height, so I want to go back and make sure I reread the problem. I found the height is 5, okay, but I'm also looking for the base. And then remember, the base is 4 times the height, so 4 times 5 is going to be 20. We can always go back and double check my answer with my measurements that I have now. 1/2 times the base times the height. 20 times 5 is going to be 100. Half of that's going to be 50 square inches. So I have my measurements, and it's 20 inches and 5 inches are the base and the height of this triangle. All right, our final example has to do with something called the area addition postulate. And the area addition postulate says the area of a region is the sum of the areas of its non-overlapping parts. So what this means is if we have an area that's made up of more than one shape, we can divide up that area into those shapes, find the area of each individual piece, and then add them together to find the total area of the entire solid. So example 3 gives us a hexagon because it has 6 sides, but this is what we call a concave hexagon because it's not a normal convex hexagon like we're used to seeing. And so there's no area formula for a concave hexagon. So something like this, we're going to want to split this up into 2 shapes that we do know how to find the area of. And I can split this up into 2 rectangles. It should be pretty easy for me to do this. So what we're going to do is just kind of take this top one right here and divide that as a rectangle on top there, and we're actually going to have a square on the bottom here. So based on measurements, we know that this blue square right here is going to be 5 by 5. On top, in green here, we have a rectangle. Now we know the top of this is going to be 9 right here. However, we're not given the length of this side over here, the other side of the rectangle. Now we know that this whole side right here is going to be 9 meters long. And I know from here to there is 5 meters. So therefore, we subtract 5 from 9, which is going to give us 4 meters for this part of the rectangle. So to kind of clean this up a little bit for you, here's a rectangle that's 4 by 9. Here's a square that's 5 by 5. And we're going to individually find the area of each one of these shapes. Now we know a rectangle, the formula is base times height. So 4 times 9 is going to give me 36 square meters as the area of the green rectangle. The blue square we know is going to be side square, so 5 times 5, which is going to be 25 meters squared, is the area of the blue square. Now based on the area addition postulate, we can just go ahead and add these 2 things together, and we can find the green rectangle plus the blue square. 36 plus 25 meters squared is going to be 61 meters squared. So the area of the entire room right here is going to be 61 meters squared. Now back to the problem in example 3. We need to find the area first, but what we have is a robotic vacuum cleaning this room at a rate of 2 square meters in 8 minutes. So what we want to do is figure out how long this is going to take to clean the entire room. 61 meters squared is the total square footage of the room. We found that by finding the area of the 2 pieces. Now we need to set up a ratio to figure out how long this is going to take. So in doing a ratio is a comparison of 2 quantities. We need to identify what are the 2 things that we're comparing. Now for this particular problem, the 2 things we're comparing are area and time. So area of carpet cleaned and the amount of time to do so. So this is going to help us set up our ratios. So the ratio that we're given is that we're able to do 2 square meters of carpet in 8 minutes. So 2 square meters is an area that's going to go on top of my ratio. 8 minutes is a time that's going to go on the bottom of my ratio. So 2 square meters in 8 minutes. Now we need to set that equal to a second ratio. So we know the whole room is 61 square meters. That's an area that's going to go on top of my ratio. And then the bottom is going to be my time, which I don't know. That's what I'm trying to figure out, so we'll call that x. So 2 over 8 equals 61 over x. We're going to cross multiply. So 2 times x gives me 2x. 8 times 61 is 488. We want to solve for x, so divide both sides by 2. 2 is going to cancel. And x is going to be equal to 244. And this is going to be minutes. So in order for this vacuum to clean this room, it's going to take 244 minutes. You can convert that to hours if you'd like, but it doesn't specifically ask me for a unit of time. So 244 minutes is a perfectly acceptable answer. All right, that does it for our lesson on area of triangles and parallelograms. If you have any questions, make sure we are writing them down on the side, and we'll see you in class.